Good morning, students. Welcome to Computer Aided Design course code P20DE102, classroom discussion topic on parametric representation of line. I am Rakesh, Assistant Professor in Department of Mechanical Engineering, Kids Warangal. Before going to start this topic, let us see the lecture outcome for this topic. After completion of this lecture, student will be able to derive the parametric equation, tangent vector and unit vector of straight line. Already you know that what is straight line. The shortest distance between two endpoints, that is called straight line. Before going to derive parametric representation of a line, in our mind two questions are raised. First one is, how is a line equation converted by the CAD/CAM software into the line database, which is at the minimum at the two endpoints of the line. The second question is, how are the mathematical requirements of an equation correlated with various modifiers available with line commands offered by common user interface. Let us now I'm going to take one line in a three-dimensional Cartesian coordinate system. Let us take, this is my line. This endpoint is P1 and this endpoint is P2. This is in three-dimensional coordinate system. This is the X and this is the Y axis. This is the Z axis. Now let us take parameter U. At P1 that value is minimum value is U equal to 0 and at P2 U equal to 1. Now I am going to draw the position vector. Position vector means join this P1 to origin point. This is the position vector P1. Similarly, I am going to join this P2 to origin point. This is the position vector P2. Now I am going to take one more point on this P1 P2 line. I am taking here. Let us assume this is the P point. This position vector is P. We don't know the P value. This P value must be lies in between 0 and 1 parameter. Now the mapping between Cartesian and parametric space. The mapping between Cartesian and parametric space. Now write the relation between Cartesian space and parametric space. Here Cartesian space means P1 and P2. Parameter means U. Now write the relation between this P1, P2 and U. Endpoint length. Endpoint length in Cartesian space. Here endpoint is P2. This is the P2 is the endpoint of this line. Endpoint length in Cartesian space. Cartesian space divided by end endpoint length in parametric space. Endpoint length in parametric space. Parametric space that equal to distance of P from P1 in Cartesian space, that equal to distance of P from P1 P1 in Cartesian space. Cartesian space divided by distance of P from P1 in parametric space. Distance of P from P1 in parametric space. Parametric space. Here endpoint length, that means P2 in Cartesian space, that is P2. Endpoint length in Cartesian space, that means P2 minus P1 is the endpoint length in Cartesian space. You can write here P2 minus P1 by endpoint length in parametric space, that means 1 minus 0, that is 1, equal to distance of P from P1 in Cartesian space, that means P minus P1 divided by distance of P from P1 in Cartesian parametric space, that is U. Here we don't know the U value, let us take U minus 0, that is U. These both are equal, so you can write here P2 minus P1 by 1 equal to P minus P1 by U. Now cross multiplication, U into P2 minus P1 equal to 1 into P minus P1. Now simplify this equation, we can write as P equal to P1 plus U into P2 minus P1. Just you can also write here U into P2 minus P1 equal to 1 into P minus P1. So you can keep P here, this minus P1 goes to this left side, so plus P1, P equal to P1 plus U into P2 minus P1. This is the equation Cartesian space. You can write in the scalar form. In scalar form, means you can take any point. This point having 3 coordinates, that means in x, y, z direction. So for example, in x direction, P1 means x1. Here P1 means x1, y1, z1. P2 means x2, y2, z2. So x equal to x1 plus u into x2 minus x1. Similarly, in y direction, y1 plus u into y2 minus y1. Similarly, in z direction, z1 plus u into Z2 minus Z1. This is the equation 1 and this scalar form are equation number 2. You can see here this is the equation only for these two endpoints P1 and P2. For example, these points are extended or outside or inside or left side. Let us see that one. For example, I'm taking this is the previous line P1 and this is the P2. Parametric values are u equal to 0 and this is the u equal to 1. Let us take one point here. This is the P3. This u value is 0.75. Now I'm extending this line from here to here. This is the point P4 and u equal to 2. Now I'm again changing this point P4 to P5. This u equal to 2.5. Let us assume this is the 2.5. Now I'm again going to extend this side. This is the P6. P6 the value is u equal to -1. Again I'm changing from P6 to P7. U value, let us assume -1.5. In the previous one we derived that is P equal to P1 plus u into P2 minus P1. This is the equation only for P1 P2 and u value. U value lies in between u less than 0 less than or equal u less than or equal to 1. We had derived this equation for u limits are 0 to 1 and points are P1 and P2. For example, I am going to write the equation for P2 and P4. So P equal to P2 plus u into P4 minus P2. Here u value is 2. You can write 2 here, u equal to. Similarly, you can write the different points and different parameter values. Now let us see the tangent vector. Tangent vector. How to calculate tangent vector? This is the derivative of this equation. That is parametric equation applied. Derive the with respect to u dp by du. That means p dash. P1 is 0. There is no u value 0 plus u derivative of u 1. 1 into P2 minus P1. So you can write here P dash equal to P2 minus P1. This is the equation for tangent vector. Tangent vector of a line. You can write in the scalar form. Scalar form, that means in terms of x, y, z. X dash equal to x2 minus x1 because the P1 having point that is x1 y1 z1, P2 x2 y2 z2. Y dash equal to y2 minus y1, z dash equal to z2 minus z1. This is the equation for tangent vector. This is the equation number 3. This is the equations are 4. Let us see the unit vector. The last one is unit vector. How to determine unit vector? We can represent unit vector n cap. N cap equal to P2 minus P1. That means the distance between the 2 points P2 minus P1 by that length. Here L equal to determinant of P2 minus P1. How to calculate determine of P2 minus P1? L equal to, that means distance of the 2 points. Now you can write the equation for distance between the 2 points, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the equation for L. So you can substitute here. You can get unit vector n cap equal to p2 minus p1 by under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. uh, okay, for solving any problem, you can remember these three equations. First one is parametric equation of line, that is p equal to p1 plus u into p2 minus p1. The second one is tangent vector, p dash equal to p2 minus p1. The last one is unit vector, n cap equal to p2 minus p1 by L. Here L means determinant of p2 minus p1. Okay, after completion of this lecture, uh, having completed the discussion on parametric representation of line, now students should be able to derive the parametric equation, tangent vector and unit vector of straight line. Further reading, uh, students are required to refer the following standard textbook, that is Ibrahim Jeed and Shiva Subramanian R.R. CAD/CAM Theory and Practice, second edition, Delhi, Tata McGraw-Hill 2010. The reading chapter is 4.5.2. Another reference book is Ibrahim Jeed Mastering CAD/CAM, first edition, New Delhi, McGraw-Hill Higher Education 2010. I hope this topic is very clear to everyone. Thank you for watching. Please do like and subscribe my channel for more updates.